So when I read these directions, a simple random sample of size n less than 30 has been obtained. Why is that important? Why is that sentence important? Why do they need to tell me that?
Central limit theorem.
Yeah, the central limit theorem. It told me it's less than 30, so what has to be true in order for my data set to be normal? Okay, so if I wanted to satisfy that, it would have to be greater than or equal to 30. In the directions, it doesn't say that. It strictly says that it is less than 30. So what is the other one it has to be then? Yes, your population has to be normal. So, either this or this. And this one, they tell me this one's not true. So we look at these normal probability plots. Number 9. How can we know if our population is normal looking at that?
Yeah.
Are there any outliers? How do you determine if there's an outlier? If one of the dots is outside the bounds? Okay. So, Adina, are there any dots outside the bounds in number 9? Not really? I think I see one if you look at the very top. You see the one at the very top? It's about... Oh, there's one? So what does that mean if there's one outside the bound? So there's an outlier, yes. But what does that mean about my population I have if it's outside that bound?
It's not normal.
Might be it's not normal. Do we agree with that? Yeah, if it falls outside those bounds, that means our data set is not normal. So what does that mean about the sample I'm going to draw from here?
It's not normal.
It's not normal because it doesn't satisfy either of those. Does that make sense? Okay, let's flip. Let's flip. Rashawn, let's look at number 10. Is our population normal in number 10?
Nah.
Nah, why is that?
It's outside the boundaries.
It is, what's it?
Dots.
Yeah, one of those dots, one of those data set points is outside our bounds, which means our population isn't normal, which means our sample's not going to be normal. Alright, what about number 11? Number 11, volunteer, James.
It's definitely because one of the dots are outside the bounds.
Yeah, once again, not normal because there's a dot outside the bound.
I don't see a dot outside the bounds.
If you look at the bottom, yeah, it looks like it's about like 45 maybe.
Barely.
Yeah, it's tough though. Sometimes they're picky about that. If any are outside that bound, then it means our population's not normal, meaning we can't do anything. So this is important. We need to be able to check this because we don't want to have to do a lot of work. So if it's not normal, we know we can't do any work. Okay. Let's look at 12. What do we think about 12? Are those data points inside the bounds, and what does that mean? Marcus, what do you say? Number 12, you say what? No. There's that one is really close, but I say that's still outside the bound. So, what that means is my population's not normal, means my sample's not normal. Okay? Last two, let's look at 13. 13, is that normal? My population is normal. So what does that mean about any sample size I take from there? That it's going to be normal, yes. And the last one, 14.
Yes.
It is. All those data points fall within those bounds. All those data points fall within those bounds. Any questions on that? How to interpret those graphs? Another thing they have there, they have the box and whisker plots. You could look at those and see if you have just kind of a skewed kind of box or a whisker to tell. I think it's easier to look at the bounds myself, so we don't really worry about the box as much. So we could look at those and be able to interpret. Let's look at number 15. Number 15. So Ms. Hill, what information does it give me in 15? So it gives me a lower bound and an upper bound. So for these cases, let's say that our data set is normal, so I can draw this normal curve. Once again, drawing the picture is going to be important. And Ms. Hill, what is the lower bound? 18. And the upper bound? Is what? 24. What I want to be able to do is find this middle point. Now, what is that middle point? What's the name of it?
Estimate. PE.
PE. It is that point estimate. Also the X bar. So I want to find the point estimate or the X bar. How could I find it given the lower bound and upper bound?
Add them
With a hand, with a
together
hand,
and
with a
then-
hand, with a hand. So you could count the difference and then divide it, but you could,
Or
there might be another way.
you just go dot, dot, dot until you get to
And I think that's what he was saying. You could you could count in, so 2319,
the
and
simple
just
man's
keep
mind.
going until you count in. But Malik, what did you say?
Add them up and then divide by.
Yeah, you can add them up, divide by 2. You can find that middle
Well, no,
point.
do all that.
So
Operation right there.
let's talk about what we were getting at over here. Finding that middle point, you keep counting. I don't find that as mathematical. I don't really consider myself a cool mathematician if I'm doing this number.
Man, when you're
Hey, but anyway it works. If that's the way it works for you, I like to have a unified way that works every time. So this is one way. 18 plus 24 looks like 42. And then 42, what do I need to do with that, Malik?
Divided.
Divided by what?
2.
Divided by 2. Okay, so 40, that looks like it's 21. So what is 21, Malik?
The mean.
It is the mean. 21 is our mean. Okay, so it's the mean, the point estimate, X bar. We're good there. I want to be able to write in confidence interval notation. Confidence interval notation. So Najee, what do I do? Confidence interval notation. Okay. Well, let's think. How did I get these numbers for the confidence interval notation over here? What is X bar? What is?
I know the 16.6, you got that from the little middle thing.
Okay, so what's the middle thing here? Okay, so 21. And that was this middle thing, this X bar, the point estimate. And then where did I get that 2.7?
They gave it to me.
They gave it to you. What is that ME I wrote under it?
I forgot
Gotta think. ME,
oh, margin of error.
margin of error. Okay, so
He said margin.
how can I find the margin of error for this one, Avery?
You subtract the bounds from your point estimate.
Oh, I can't hear Avery. Can't hear Avery.
You subtract the bounds from your point estimate.
So, Avery, what did you say?
You subtract the bounds from your point estimate.
So, I subtract, so 21 minus 18,
Yeah.
and it looks like I get 3. Now, you could check again. You could do 24 minus 21. That's also 3. You could do them both. I'm only going to do one. So I get 21 plus or minus the 3, that margin of error. And that's how I can write this in confidence interval notation. Any questions on that? Any questions on where I got 3, where I got 21 from? Yes.
Make some more.
Yes. You guys try 16 and 17. I'll be walking around. If you have questions, please ask. You try 16 and 17.
Which one did we just do? What number was it?
We did 15.
15. Okay.
You guys try 16, 17. Make sure you can do this. find what? But when I check for later, I'm gonna see something.
I'll do 17.
Alright, do 17. How do you feel about this? White on rice or something? What's Cardi saying? What would make me cool?
It's really bad.
Nah, come on. You let me down. Good? Good. That's the best thing I've ever
But there will be a catch. There's gotta be.
Probably would be.
Oh, not for
Man,
me.
there's always a catch.
No.
We about to be right.
Find the highest
You wanna go to the locker?
This time you documenting the movement over there?
Always.
You and Jackson.
What is that?
This one I'm yeah.
What?
Was it going by itself? I was about to say, you'll detect this.
Oh my God. 16. You do number 61.
Oh, Amazon or something a couple years ago. No, maybe Best Buy.
Yeah, they usually have high tech. It's a cute.
I like it.
That's the beach. Can I get some water after?
Yeah, when your brother comes back.
Not talking about
Oh man, I missed that. Carter dancing. Oh wait, we're getting some now. There we go.
That's what I'm
Oh,
saying.
it's going to be the difference.
Knock it out real quick. Get the fast
Your,
one.
your medium and your upper back.
Alright, we'll go over at 9:41. We'll go over at 9:41.
Let me put it on the board.